This is the last of the word problems that Cortagio had sent, and they're all interesting because they're all involving distances and rates and times, and they all involve you having to do a little bit of implicit algebra without having to explicitly solve for values of variables, and that's why they're fun. So this one says Anne and Betty, two cyclists, start simultaneously. Anne at point A, and Betty at point B. Betty at point B. They travel to each other at constant speeds. So let's say that Anne is traveling with velocity A, and Betty is traveling with velocity B. Constant speeds. They pass each other in 30 minutes. Okay, so they're going to pass each other someplace in between A and B. I'll just arbitrarily draw that. They're going to pass each other there. And what are these distances? It took them 30 minutes to both get to this point, right? They pass each other in 30 minutes, and Anne headed for point B arrives there in another 20 minutes. Okay, so this distance takes Anne 30 minutes. So what's the actual distance? So it's always useful to write distance is equal to rate times time. So what's the actual distance she traveled? Well, the rate is VA. She traveled a rate of VA, and her time, they tell us, it took her 30 minutes to get there. So VA times 30. Let's say this velocity is expressed in minutes. Fair enough. And then Anne headed for point B arrives there in another 20 minutes. So this is going to take her another 20 minutes. So this distance right here is what? She's going at the same velocity, but it takes her 20 minutes. So the distance is velocity times time. So it's VA times 20, or 20 VA. Fair enough. How many minutes after Anne arrives at point B will Betty arrive at point A? So Betty was going in this direction. They meet right here, and then she keeps going and hits point A. So the key realization here is that this took Anne 30 minutes to get here, but it also took Betty 30 minutes to get here. So what's this distance in terms of Betty's velocity? What's this distance? Well, distance is equal to rate times time. It took Betty 30 minutes to go this distance at a velocity of VB. So it took her 30 VB meters or whatever. Actually, we don't even have to specify the units, whatever the units the velocity is in. If it's in meters per minute, then this is the distance in meters. It takes her, this distance is 30 VB, right? So essentially, we just have to figure out how long it takes her to travel this remaining distance, and we would have solved the problem. So how can we do that? Well, we can already set up a relationship between VB and VA, because this distance is the same. It doesn't matter how fast you travel it, the distance doesn't change. So we know that 30 times Betty's velocity is equal to 20 times Anne's velocity, 20 VA. And so if we wanted to express Anne's velocity in terms of Betty's velocity, just do it that way, we get, let me scroll down a little bit. If we divide both sides by 20, we get 3 halves of Betty's velocity is equal to Anne's velocity. Fair enough. So what is this distance in terms of Betty's velocity? We know it in terms of Anne's velocity. In terms of Anne's velocity, it's 30 times Anne's velocity, right? So what is 30 times Anne's velocity in terms of Betty's velocity? Well, if we multiply this times 30, that's 30 times Anne's velocity. So we can multiply both sides of this times 30. So if you multiply 30 times here and times 30, this is the distance. This distance right here. Anne's velocity times 30 minutes. Took her 30 minutes to travel that far. So this is the same distance expressed in Betty's velocity. So let's see, 30 times 3 is 90, divided by 2 is 45. So it's 45 VB. So this distance up here is 45 VB. So distance is equal to rate times, so this is rate times time. So this is how many minutes it took Betty to travel this distance. So what is the question asking us? How many minutes after Anne reaches at point B will Betty arrive at point A? So they both reach right here. In another 20 minutes, Anne gets here. And how many minutes? In another 45 minutes, Betty will get over there. Another 45 minutes. So it takes Anne 20 minutes to get here. It takes Betty 45 minutes to go get here after their meeting right at the center. So it's going to take Betty another 25 minutes, right? After 20 minutes, Anne is here, and then we have to wait another 25 minutes for Betty to get here 45 minutes after this meeting. So the answer is 25 minutes. 25 minutes. How many minutes after Anne arrives at point B will Betty arrive at point A? Yep, 25 minutes. They could have just asked how many minutes after the meeting will it take Betty to reach point A. It would have been 45. But they want to know how many more minutes after Anne gets there. Anyway, thought you would find that useful. And final time, thanks to Cortagio for sending that problem.